Hello, my name's Thanom and I'm from UNSW. Today I'm going to go through this problem from section 1.4 of MATH1011 Calculus. So actually it's a bit of a combination between questions 2 and 3, and I'm going to focus on the functions that they give in parts A and part C. So in question 2 they ask us to sketch these functions. So first of all, y equals x, that's a linear function, it goes through the origin, it's got a gradient of 1. So it looks like this. Now we're asked to determine from the graph whether the function's odd, even, both or neither. From the graph we can see that there's rotational symmetry about the origin, that if you picked it up and rotated everything 180 degrees, it would sit on top of each other. So from that we can determine that y equals x is an odd function. That's what it means to be an odd function, since its graph has rotational symmetry about the origin. So by that I mean 180 degrees, we're turning 180 degrees. Now, it's not even because it doesn't have reflectional symmetry, okay? So it's not symmetric about the y-axis. So over here we want to sketch y equals cos x. Cos of 0 is 1, so it starts at 1 and heads down to minus 1 and then back up to 1 by 2 pi. And does the same on the other side. So it heads down to minus 1 and then back up to 1 by the time we're at minus 2 pi there. And it keeps going. So we can see that the cos x graph is symmetric about the y-axis, and that tells us that it's even. So y equals cos x is an even function since it is symmetric about the y-axis. Now even functions, you see, because they're symmetric about the y-axis, this was x here, say, then cos of x gives me the exact same value as cos of minus x. Okay, so since it's even, we know cos of x is the same as cos of minus x. In general notation, that's if f of x is the same as f of minus x, you have an even function here. Okay, whereas here, right, so your general rule for odd functions is that f of minus x is the negative of f of x. Right? That's obvious here because minus x is the same as minus x. So I might not write that one down. In question 3, they've asked us to determine whether this function x cos x is odd, even, both or neither. So that's the product of these functions we had in part A and C. So the idea is that we have an odd function multiplied by an even function, and the product of that will be an odd function altogether. So since, and I'll call it f of x since we'll use that again later. So since f of x equals x cos x is the product of an odd function, that's the y equals x, and an even function, that's the y equals cos x, f of x equals x cos x is an odd function. So the product of an odd and an even function will end up being odd. We can verify that by considering f of minus x. So if f of minus x is the same as minus f of x, we know it's odd. So f of x is, f of minus x is minus x times cos of minus x. So if f of x is x cos x, f of minus x, we just put minus x everywhere there's an x there. So that's a minus x times cos of x. I know cos of minus x is the same as cos of x because I know cos is an even function there. So that's the same as minus x times cos x, which is minus f of x. Okay, so since f of minus x is minus f of x, f is indeed an odd function there.